Hey guys, welcome to part 2 of your lesson 1.2 video lesson. For the remainder of these slides, I'm going to give you some examples, help you with the positive and negative counters. Remember, you can just draw yourself plus and minus signs to model the positive and negative numbers. So I'd like you to copy all of the steps down and work in your outline. So for example 1, we have negative 12 plus 7. So here are negative 12 reds and 7 positive. So if you notice, there are red and yellow counters. So that means we can make 0 pairs. So those cancel. Those cancel. Notice I'm taking away, I'm not adding on to this set. Cancel, 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 cancel. Okay, so I am left with this set here. I am left with 1, 2, 3, 4, 5. So negative 12 plus 7 is equal to 5 red. The reds represent negative, so my answer is negative 5. My next example, I have negative 6 plus 10. So that looks like this. I have negative 6 red, 10 yellow. So what I'm going to do is take away 0 pairs. So this gets taken away. I am going to take this set away. I can take this set, this, and this. My final counters that are left over are 4 yellows. And remember, 4 represent, or yellow represents positive. So my final answer is 4, positive 4. And finally, I have negative 4 plus 5. If you notice here, I have 4 reds, and then I have 5 more red. You notice that I don't have a mix of red and yellow here? So I can't take anything away. So since both of my signs are the same, I'm going to add all of these counters up and get a final answer of negative 9 because red counters represent negative. Okay, if you need to pause here, if you need to go back and listen to this again, go ahead and do so. I will be moving forward to page 10. Okay, just a quick review on the word opposite. It's just 2 numbers that are the same distance from 0, but on the opposite side of 0. Additive inverse, the sum of an integer and its additive inverse. You can fill this word in. Or opposite is 0. So if you notice, I have 6, I have negative 6. That's the opposite part. I am adding, that's the additive part. And it equals 0. Same with the next example. I have negative 25 and positive 25. I am adding them together. They will always equal 0. Remembering this rule will help you through a ton of different math questions, because some students don't recognize opposites and spend a lot of time when we do order of operations. Okay, page 12 of 15, we're going to find 5 plus negative 10. So what we're going to do is, I'm on the wrong spot, is since the signs are different, I have a positive here and I have a negative here, and they're being added to each other. So I can draw this out for you. I have 1, 2, 3, 4, 5 positives, and I have 10 negatives. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if you notice, I have a mix of 2 colors. I have 5 positives but 10 negatives. So the rule I want you guys to start to recognize is, in addition, and you can write this down, in addition, when the integers have different signs, you will subtract the larger absolute value from the smaller absolute value. Then take the sign of greater, I'm just going to abbreviate absolute value to ABS. So then you're going to take the sign of the greater absolute value. So some of you may be sitting there saying, okay, what does all of that mean? So what I'm going to do is, since the signs are different, I'm going to take the absolute value of 10, negative 10. I'm going to take the absolute value of 5. The absolute value of negative 10 is 10, and the absolute value of 5 is 5. So I'm going to take the bigger number 10 and subtract 5 from it. So 10 minus 5 is 5. So at this point, I hear it all the time. Students say, well, why am I subtracting when there's a plus sign between? Let's go to my diagram over here. I'll move this guy. Let me just shrink this a little. All right, so I'm going to show you why we're subtracting. So if you look at this model over here, I have a mixture of positives and negatives. So what I'm going to do is find zero pairs. So if you look, I have more negatives than I do positives. But you notice when I make a zero pair, I've taken one away. So that leaves. I'm going to take this zero pair and get rid of it. So when you get rid of something, you're subtracting. So I'm going to get rid of this pair, and this final pair. So if you notice, I subtracted off 5 sets. So this down here is what I'm left with. So if we go back to this rule up here, I took 10 and subtracted 5. I have 5 left over. Now we're going to look at the bottom phrase. Take the sign of the greater absolute value. Who gave me a bigger absolute value, the negative 10 or the 5? And since 10 is bigger than 5, the original value was negative. So my final solution is negative 5. Okay, so we're going to use the sign of negative 10. Okay, and our solution is negative 5. Okay, same idea here. We're going to, since the signs are different, we're going to take the absolute value of both the negative 3 and the 7. Notice that the greater absolute value we put first, because we're going to take 7 and subtract the absolute value of negative 3 is 3. So 7 minus 3 is 4. Again, for those of you asking why we're subtracting, here's a model. 1, 2, 3 negatives. And I'm going to add to that 1, 2, 3, 4, 5, 6, 7. Okay, and I will take away the zero pairs. Subtract 1, 2, 3. You notice how I took these 3 away? Because my colors are different. So my final solution, if I look at the absolute values, 7 has a bigger absolute value than negative 3. So I'm going to keep my answer positive. If you look at the diagram, you notice I have more positives than I do negatives. So my solution has to be positive. Okay, I'm going to use the sign of 7. My final answer is 4. All right, next example, negative 12 plus 12. Hopefully you guys remember the rule. The solution is 0 because we're using the additive inverse property. All right, 12 and negative 12 are opposites. And the final page, I have 6 examples here. What I'd like you to do is pause. Try these on your own. You can use counters, you can use the rule, you can use a mixture of both. When you're ready, I'm just going to show you a quick demonstration, and I'm just going to give you the answers to these 6 questions. If you have any problems in the assessment, you will let me know that you had questions on page 15, and we can go over some of these in class. tomorrow. So here are the solutions. Number 4, I have different signs, so I'm going to subtract 11 and 2, and that's going to leave me with 9, positive 9. I have more positives than negatives. For number 5, again, my signs are different, so if you look at the counters, I have different colors. So I'm going to take away 8, 1, 2, 3, 4, 5, 6, 7, 8. That leaves me with 1, 2, 3, 4, 5. So my final answer is 5. Or you can just subtract the absolute values. 13 minus 8 equals 5. Next example, 9 plus negative 10. The signs are different. I have a positive, I have a negative, so I'm going to do 10 minus 9 to get 1. If you notice, these are 0 pairs that cancel out, leaving me with 1 negative. If you notice, the absolute value of negative 10 is bigger, so my answer has to be negative. Right, I'm going to erase the work for 4, 5, and 6, so I have a clean sheet to work with for the last 3. If you need any of this work, please pause now. Okay, number 7. Since my signs are different, I have different color counters. We're going to take the absolute value of negative 8 to get 8, the absolute value of 4 to get 4, and subtract those. Okay, 1, 2, 3, and 4. My final solution is 4 negative, because the absolute value of 8, is greater than 4. Next, 7 plus negative 7 is 0. We have additive inverses. And for number 9, it's also 0 because you're adding opposites to one another. Thank you for your attention and effort. See you guys in class tomorrow, and be sure you do your assessment.